Hi, so this section of the video is to know about Go Green Technologies Mobile IoT Lab external connections. As you can see, there are a couple of wires which are connected between the motors and the board or from the microcontroller pins to the board. So let us see various connections currently connected. If you see, first of all, the power supply to this board, right, you can see 9 pin D type female connector is mounted on the PCB. If you wish, there is a external power supply provided to you which is having a 9 pin D type male connector. You can connect it to this board as a power source. The moment if you plug in, right, it provides you on the board various power sources, that is plus 12, minus 12, plus 5 and variable DC. On board there is a 3.3 volts regulator IC is there, and there is a on off switch in order to connect this power to the board. This is one way of giving the power to the board. The other way is, as you can see, there is a microcontroller and there is a USB, mini USB connector is there, where you can use the connector USB cable interface, and the other end of this USB connector you can use either adapter, DC adapter of 5 volts, or you can connect it to the either laptop or computer USB interface, where it will provide you 5 volts and 500 milliamperes of current. So these are the two ways of giving the power, either through microcontroller's USB or through external DC power source. When you are programming the microcontroller, you don't need this power supply. So without this power supply also, you can still program your microcontroller, because microcontroller power supply is independent. However, if you do not want to power this microcontroller through USB, if the microcontroller is already programmed, then there is a 2-pin jumper is here. If you close this jumper, then this external power supply 5 volts is given to this microcontroller 5 volt supply. Since there is a 3.3 volts regulator on the microcontroller is powered 3.3 volts by its own power supply. So we are not providing 3.3 volts to the microcontroller externally. The CPU itself has a 3.3 volt supply on board. So since the microcontroller is working on 3.3 volts, make sure whenever you connect any of these interfaces like LEDs, LCD or some external sensors, the voltage should not exceed more than 3.3 volts. And if you are connecting any motors or LEDs, make sure you are not supposed to draw more than 10 milliamperes of current. So that is the limitation of generally any microcontrollers. Now, apart from this DC power supply cables, let us see how the motors are connected, or how at least a few sensors are connected. As you can see, first of all, there is a stepper motor connector is there. The stepper motor connector, which is what you can see is having 5 wires, starting with first pin is a red wire, then there is a yellow wire, then there is another yellow wire, then pink, and then blue. So the first wire, generally we put a dot mark here, that is pin number 1. That pin number 1 is nothing but plus 12 volts power supply. Rest of the five wires are actually meant for the motor connections, motor output connections, winding connections. So on your board, wherever M in motor M means that is the first pin. From there first pin is starting. There exactly this red wire should be connected of the motor. So that is the output of this L293D motor driver is connected. First is red wire, which is plus 12 volts. Then the first wire is dark yellow, then light yellow, then pink, then blue. So all these 5 pins in the same series they are connected. 4 motor windings and 1 plus 12 volts common winding of the stepper motor. If you have 2 DC motors to be connected, then do not use the first wire. Output of this, that is second and third, you can connect one DC motor, and this fourth and fifth you can connect the second DC motor. That is as far as the motor connections are concerned. Okay, now as far as the servo motor which is a 3-pin connector. In these 3 pins, right, the first pin what you can see is there is a orange, then center is there is a red color, and the third pin is a black color. So if you consider the first pin where servo motor S letter is starting on the board, that is first pin where orange is connected, right, orange pin. And the center one, red color, is nothing but 5 volts, and the black one is actually ground on the board. So this is as far as your motor, which is a servo motor, where male connector is provided on the board. On the male connector, so use the orange, that is the first one where S letter is there, that is nothing but pin number 1, which is signal input to the servo motor. Second is 5 volts, third is ground. So this is as far as servo motor, stepper motor interfacing to the Mobile IoT Lab is concerned. Now if you have any relay, if you want to connect any external relay, as you can see there is a relay, pins are provided, transistorized circuit is provided here, which we will explain in some other section of the video. So a relay can be connected here, or you can also connect a 12 volts DC motor. Alright, so this is as far as the output for the motors, stepper motor and servo motors are concerned. Now let us see the inputs to the motor. The inputs of the motor, where you can see you can use any these connectors, that is female male connectors, which are connected to the microcontroller. Actually speaking, you can use any of the GPIO lines, that is nothing but data lines of the microcontroller. There is no fast and rule that you have to use a specific connector only, specific pin only has to be connected to the inputs, because finally they are digital input output lines. It is your choice which pin to be used. However, since we have already provided some programs, in the programs we have initialized some of the pins, and if those programs directly as it is, if you want to use it without modifications, then you connect the way we have connected. Nothing but stepper motor inputs, the first pin, as right now we have used a black wire, but however in your case it could be some other color. So the first pin here is connected to the, from the microcontroller left side, from the bottom side, third pin, right. We will explain you in the circuit diagram also. So that is, which is nothing but IO13. So IO13 or the third pin is connected to first pin. Then the next pin, that is the fourth pin, is connected to here second pin, then fifth pin, then sixth pin, then seventh pin. So consecutively 4 wires from the third pin, from the this side, from USB side, left side, third, fourth, fifth, sixth, nothing but IO13, IO12, IO14, IO27 of the microcontroller are connected to this motor driver inputs, that is your M1, M2, M3, M4 of the driver. The fifth pin of the motor input, you can also use a GPIO line. However, we have directly connected to the 5 volts, right? because you want to permanently enable this IC. If you want to through program, if you want to enable or disable, then this chip enable of the L293D, you can connect it to some motor, some GPIO line, and in the software you have to make it high. But currently in the program we didn't use that pin, so that's why we have connected permanently to the VCC. So this is as far as the inputs are concerned. We will explain you with the help of the manual also which pin is connected where. Similarly, as far as a servo motor is concerned, servo motor requires only one input line where you have to program it through your generating some pulse. So that we have used from the top, from the left side, 1, 2, 3, 4, 5 and sixth line. So this sixth pin is nothing but IO33. So IO33 of your microcontroller is connected to the servo pins, the first pin, because the first pin where S letter is written, that is nothing but your signal input. Or in short, we are connected to the orange wire of your servo motor. So this is as far as your stepper motor and servo motor, microcontroller interface and motor interface are concerned. For motor interface, stepper motor, output where, as you can see, step SM output is written there. There only you have to connect. And the stepper motor input is SM input is written here, where we have connected to the microcontroller. Similarly, for servo motor we have not used any driver IC. It is directly, since the driver is there inbuilt inside the servo motor itself, so we don't need any external IC. So that is why the 5 volts and ground are already given. Only the signal input for the servo motor we have used. We can use any GPIO. However, we have used IO33, which is nothing but from the top left side, it is the 6th pin. Now when it comes to some more interfaces which are nothing but LDR, LM35, or if you want to use buzzer, you can use any of these pins. But however, this LM35 LDR, they are analog inputs. So you require a to D converter. So since in the program, and of course this microcontroller is having all the channels are analog inputs also, but then looking at our LCD interface and motor interfaces, a specific pins we are using as an analog to digital converter inputs. So from top left side, the first pin we are not used because that is enable. From the second pin is connected to LDR, that is analog input, and the third pin again analog input, we have connected LM35. But however, I said it is your choice which pin you want to use. Similarly, there is an optocoupler, you can use some another analog input. And as far as buzzer is concerned, buzzer is a output, it's not input. So output, any GPIO you can use it, since it works on digital high and digital low. From the right side from bottom, we have used the third pin. So this is as far as the interface of this microcontroller and various digital as well as analog input outputs are concerned, including your motors, that is stepper motors and servo motor connections are concerned. In some other video, I will explain you the remaining circuit diagram where you have a function generator and some signal conditioning circuit, some LEDs interface, some 7-segment interface, some LCD interface, some switches, and also there is a potentiometers and there is an optional piggyback connector is there. That I will explain you some other video. So let me explain you whatever so far I explained the connector interface. The same thing I will explain you with the help of a circuit diagram which I have shared you in the manual, that is Go Green Technologies Mobile IoT Lab manual. If you refer to the manual, this is the manual we have provided to you. Okay, so let us see the board details with the help of the manual. The manual which I have provided to you, in that if you look at the last last page of the manual, the connector details are provided. As I was explaining, there is a 9-pin D-type connector. Through external power source, you can provide +5, +12, -12 and variable DC. And through your microcontroller ESP32, there is a USB interface is there. You can power the board with the help of this USB cable of 5 volts. And 3.3 volts is generated on the board itself. If you want to provide the power through microcontroller without USB, then this 2-pin jumper is there. If you close this jumper, then 5 volts, external 5 volts is provided to this microcontroller. Then on board the microcontroller, it generates the 3.3 volts. I was explaining about motor connectors. If you see, there is a motor, stepper motor output, stepper motor input. So the stepper motor output, pin number 1 is this, where M letter starts from pin number 1. There your motor, the 5-pin connector which is having a red wire should goes to M, where M letter is given, that is the 12 volts. After that Q1, Q2, Q3, Q4, that is the motor driver's outputs, right? 4 windings are connected to the second, third, fourth pin of the stepper motor output driver. When it comes to servo motor, as you can see, 3-pin male connector is there, where S letter is written, that is nothing but first pin. That should go to the servo motor's orange pin, which is the first pin. Then center pin is 5 volts, the third pin is ground. Now inputs, which pins of the microcontroller should be connected to this motor drivers. Though you have a choice of choosing any of these pins, any of the GPIO pins, however, like I was telling, if you look at the programs which I have provided, without modification as it is, if you want to use, then you use the pins which we have used in the program. Starting from the left side, third pin, here we have used the third pin of your GPIO, nothing but IO13 is connected to here in stepper motor, that is pin number 1, where S letter is written, that is a pin number 1. So this 1 should be connected to this third pin. Then the fourth pin should be connected to the here second pin. Then fifth pin to the third pin and vice versa. So all 4 pins. Nothing but IO13, IO12, IO14, IO27 consecutively. The fifth pin here we have not used in the program. If you wish, you can use this pin connected to some other GPIO pin, but however in the program you have to make it active high in order to enable this motor driver. Otherwise this fifth pin connected to this 5 volts connector, so that it's permanently this motor driver is enabled. So that is how you can interface this motor driver to microcontroller GPIO pins. When it comes to servo motor is having the signal input, the first pin, where S letter is starting, orange color. You take a male female connector, and that orange pin you connect it here on the IO33, which is nothing but from the top side, left side, 6th pin. Because in the program we have used the same pin. I will explain you through circuit diagram also. But however, if you can modify the program, then it is your choice. Wherever you want to connect, you can connect it. Now coming back to the some more sensors like optocoupler, LDR, temperature sensor, LM35, buzzer. So these are the sensors are there. Some of the sensors, like we have provided the connectors, right? So you can externally also connect it, like DHT11, BMP, pressure sensor, gas sensor, ADXL, like that you can based on your projects, you can keep on interfacing ultrasonic sensors and so on. So that I will explain you once again with the help of the circuit diagram. But right now, since on board we have few sensors, how they are connected. Again, it is your choice, but still LDR, this pin we have connected to the second pin from the top left second pin, because that is the first channel of the ADC. So similarly, the temperature sensor LM35, this pin with the help of female connector, this LM35 we have connected to the third pin, third, that is analog input of the microcontroller, and so on. Similarly, the buzzer we have connected this SP pin to the right side from bottom, we have connected to the third pin. So because like I said, that is how we have written the program, but still you can modify them. So at least in this video, let me explain only this much. Rest of the circuit diagram and its significance, I will explain you some other part of the session. Okay, coming back to the again connectors. Power supply connector, I was telling you, this is a 9-pin D-type female connector which is there on your PCB, where pin number 1 and 2 through external power supply source we are giving, as you can see, that is the minus 15 volts. Then pin number 3 and 4 is plus 15 volts. Pin number 5 we have connected variable DC, and pin number 6 and 7 is connected to 5 volts, and pin number 8 and 9 is connected to ground. And we have provided a on-off switch so that this 5 volts and ground you can make or break the connections. And there are two LEDs which will indicate, one is connected to variable DC, that is nothing but this. Second is connected to 5 volts, so that whenever you connect this connector and switch on the power supply, these two LEDs will indicate 5 volts and variable DC is available or not. Okay. Then we will discuss the remaining circuit diagram some other videos. I was telling about the interface of the microcontroller. Though you can see it is having a total number of pins 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 pins on the left side, 15 pins on the right side. Now how do we count? Left side top, first pin is enable, right? So the microcontroller, whenever you want to program it, you can press this button, reset button, enable pin. Sometimes the compiler will ask you to press the reset button to program the CPU. Okay, otherwise I was telling about the motor interface. That is, as you can see here, IO13, IO12, IO14, IO27, M1, M2, M3, M4. These are the 4 pins we have used for connecting the stepper motor inputs. Similarly, servo motor, IO33, that is nothing but from top 1, 2, 3, 4, 5, 6, 7. The 7th pin is connected to the servo motor as an input. Similarly, speaker or buzzer, from the right side you can see 1, 2, 3, or serially if you see 16, 17, 18th pin is connected to the buzzer input. Now when it comes to some sensors, LDR and temperature sensor, since the analog inputs, though all of them have the ability as analog inputs also, but for the convenience we have used D36, what we named as a AOP1. D36 we have connected to the sensors like LDR, and D39 we have connected to the temperature sensor LM35. And relay, if you are interested, you can connect it to D32. That's how we have written some programs. Let's not discuss about other interfaces like our LCD and all, that we will discuss in some other part of the video. I was telling about the external power supply. Without using USB also you can give the power, because if you close this jumper, then through external power supply this microcontroller will be powered up. But please make sure none of the pins you cannot give more than 3.3 volts, and do not draw the current more than 10 milliamperes of current, otherwise this IC will be damaged, CPU will be damaged. Okay. So I was telling about how the motor is interfaced, stepper motors or DC motors. The L293D, you can see a 16 pin IC. Pin number 1 right, and pin number 9 is actually enable signals. What we have done is this, through a jumper wire we have connected to 5 volts. That's why we said the fifth pin is connected to 5 volts, so that permanently this IC is enabled. Or you can also connect the fifth pin to microcontroller's GPIO pin and make it active high, so that this IC will be permanently enabled. That is also through software you can make it on and off. When it comes to inputs of the microcontroller, M1, M2, M3, M4, which are connected on this connector SM input, M1, M2, M3, M4. This is what I was telling. M1 stepper motor input pin number 1 connected to microcontroller's IO13, IO, and second is IO12, third is IO14, and the fourth is IO27. Nothing but like I was telling, this IO13, IO12, IO14, IO27, M1, M2, M3, M4. It is your choice, right? In the program you can change through software also. But however, since we have provided some program, I was telling that we have used these pins. And when it comes to output of this L293D motor driver, what we have named as a stepper motor output, first pin is common, which is 12 volts. Then the windings are connected on Q1. That means this IC's output Q1, Q2, Q3, Q4 are provided on this connector Q1, Q2, Q3, Q4. So the motor connector, if you see, red wire should goes to plus 12 volts. That is pin number 1. The dark yellow goes to the pin number 2, light yellow pin number 3. Then the subsequent pins, that is pink, goes to the fourth pin, and then the blue goes to the fifth pin. So you connect the stepper motor here, and the microcontroller's outputs you connect on M1, M2, M3, M4, and fifth pin you connect it to 5 volts. So this is how we have connected the stepper motor. Instead of stepper motor, if you have two DC motors, only difference is Q1, Q2 you connect it to one DC motor, Q3, Q4 you connect it to other DC motor, and don't use the first pin. Then by writing the program where you can, if you make M1 on, M2 off, then this DC motor will rotate in one direction. Then M1 off, M2 on, then it will rotate in the different direction. Similarly, M3, M4 will drive the another DC motor. However, in stepper motor, we will explain you in the program, one winding at a time you have to energize. That is when M1 is on, M2 is off, M3 is off, M4 off. And when M2 is on, other windings are off, and so on. We will see about the software at later stage. Similarly, the servo motor. Servo motor is a 3-pin connector. First pin, that's what I was telling, which is an orange pin connected here, which is a signal input. However, the second pin, red wire, is connected to 5 volts. Third pin, black wire, is connected to ground. So this is how directly you can connect the servo motor 3 pins. And from the microcontroller, the first pin we have connected to the, if you remember, that is this pin, 7th pin, servo, nothing but D33 is connected here. Now the sensors, LDR, temperature sensor, optocoupler, and other optional sensors are there. It is your choice. You can connect any pins of the microcontroller, but since we have already mounted LDR, LM35, speaker, and optocoupler, just for namesake, though we have not permanently connected, but like I was telling, LDR pin, any one of these two pins, you can connect it to the AOP, that is nothing but analog input pin of the microcontroller, pin number 2. And LM35 output, you can connect it to pin number 3, nothing but here, that is pin number 2. D36 we have connected the LDR, and D39 we have connected the LM35. Similarly, the fourth pin, D34, you can connect to the optocoupler, and so on. So as long as the pins are free, you can connect rest of the sensors like ultrasonic sensor, touch sensor, gas sensors. All these things is your choice. Do not make it too complicated by interfacing all of them. Just for demonstration purpose, right now few of them we have interfaced, but based on your application it is your choice. Alright, so this rest of the circuit diagram will explain you in some other part of the video. And this is your placement of the components, and this is what I was telling, how the stepper motor connect looks like. This red wire, then dark yellow, light yellow, pink and blue. So red wire is the pin number 1, wherever the stepper motor output connector is written, there M letter, wherever M letter starts, there this red wire should go. Similarly, servo motor, if you see the yellow wire and orange wire, then the red wire and black wire. So this orange color, you connect it where servo motor S letter is starting, there you connect the orange wire. Then subsequent red wire goes to 5 volts and black wire goes to 5 volts, ground. While giving the input also, the first pin is your input connected to the microcontroller. So that's all as far as this part of the video section is concerned. I had also provided the connector diagram. Like I was telling, if you look at this microcontroller, 15 pin on left side, 15 pin on the right side. Pin number 1 where enable, where we have to, while programming, we press the enable button, which is provided reset switch is there on the board. However, you can see all of them are ADC pins. ADC 0, ADC 3, 6, 7, all this orange color, green color. These are all analog inputs. Whenever you have analog sensors, you can connect to these analog inputs, right? Any analog sensor. But otherwise, as far as the digital is concerned, you can see GPIO. Almost every pin act as a general purpose input output lines. They can be active high, they can be active low. It is your choice. But then it is which motor to be connected, where to be connected is your choice, though we have connected to a specific pins like I was telling, GPIO 13, GPIO 12, GPIO 14, GPIO 27. These 4 pins we have used for the stepper motor. And then I was telling about my speaker, I have connected on GPIO 15 and so on. So at this point of time, let us stick to this much, that how the motors and sensors are connected to this microcontroller. Since we have provided some programs, let us see how those programs you can download after connecting them. Of course, you have to power up the board and verify those programs are working or not. I will explain you the programs maybe in some other stage of this session. Thank you.